Let's try that one more time. Good morning, class.
Good morning, sir.
Excellent. All right. Today we are moving on to the next section of logic. So we had the test yesterday over logical form with a few things on definitions. Overall, I was quite happy with that test. I think you guys did pretty well as a group. Now the trick with logical form is that it's the beginning of all the different ways we can manipulate sentences. Once we have a proposition in logical form, we can change it around and do more with it. Today we're going to get into 3 new concepts that we need to learn, and then I've got 2 worksheets for you guys to practice on that are both located on Canvas. So, if you have a set of notes going for this section, this would just fit in right in with the next bit. We need to talk about first about something that we have sort of already done, but haven't actually gotten to the drawing part of this. Do I have any artists in the room? Do I have any visual thinkers? People who I get it when someone draws it on the board a lot better. Okay, good. A marker? Your best bet is what was Mr. Bradshaw's room downstairs. There's a ton of extra markers in there. Good luck. 144B. Okay. So, for visual thinkers, I think this is going to be a very helpful set of diagrams. For the rest of us, it's still a very helpful set of diagrams. The diagrams I'm talking about are all illustrated up on the board, and I'm going to do some examples for these on the whiteboard in just a few moments. These diagrams are in your textbook, chapter 5, section 5. They're called Euler's circles. They're named for a Swiss mathematician whose last name was Euler. I believe, have y'all hit his stuff yet? Yeah. I remember Miss Lewis corrected my pronunciation of his name. I called him Euler last year. Apparently it's Euler. That being said, he did a lot of interesting things mathematically, but for our purposes, we are interested in what he does with logic. Euler took these whole ideas of propositions, and he figured out, how do I demonstrate the extension of both parts of a proposition? How do I show the relationship of the subject to the predicate based on the sentence pattern? And that's where these 4 diagrams come into play. So, I don't know if you were taking notes and somebody will let you draw in your notes, but that might be a helpful idea. Cameron, if you want to eat your snack, you should eat it, rather than playing basketball with your snack. So, thank you. All right, so we're making visual the comprehension of both the subject and the predicate in Euler's circles. That's really what the goal is. Trying to show what all is in the subject and what all is in the predicate. How are they, in fact, connected? So, 4 diagrams. An A-pattern sentence. For example, let's say the sentence, all dogs go to heaven. Well, from what we've already covered, and hopefully everybody is clear that we need to find the subject, we need to find the predicate, we need to mark the quantifier, and we need to be aware that this is has a positive quality. So in logical form, this one's going to come out as all dogs are that which go to heaven. Okay, well that's what we did all of last week, and into this week. What we need to add then is a representation of this. This is where Euler's circles come into play. Well, dogs is my subject. And in this kind of sentence pattern, dogs is all inside of that which go to heaven. So what this shows us is that the entirety of the subject is inside of the predicate. There's no dogs. If this sentence is a true sentence, there are no dogs that are not going to heaven. Dogs are completely inside of that which goes to heaven. Now notice what else it shows you though. This also shows you there's a lot of other space in this outside circle. There might be other things that are going to heaven. There might be, we could have caterpillars over here. Hopefully we have people maybe in this block. Who knows? Maybe we have triangles in that block. There could be all kinds of other things that are simply not in the sentence. But from this sentence, we know that all dogs are inside of the category of things that are going to heaven. This just gives us a way to show that visually. Everybody with me so far? Okay, that's how an A-pattern sentence works out. Now an E-pattern sentence changes the game a little bit. Where here, Now, the only thing that really changes in my sentence structure is that I keep the universality, but now we're talking about no dogs go to heaven. Well, in that case, now I've got no dogs or that which go to heaven. When I represent this visually, what I've got going on, now I have two circles. I've got dogs, and I've got that which go to heaven. Okay? What this diagram shows us, where this is my subject, this is my predicate, this shows us that each of these are completely distributed. Meaning, we're talking about all of the dogs, and we're talking about all of the things that go to heaven. And there is no connection between these two. So when we have a universal negative proposition, what we're dealing with is the fact that there is no connection between subject and predicate. Questions so far? Everybody good? Hopefully that makes sense at this stage of the game? Okay. Let's move on to an I pattern sentence. Now, this is where this gets a little bit trickier. In an I pattern sentence, now of course we're talking about some dogs are that which go to heaven. And here we're dealing with, this will be our logical form version. Well, now Euler kind of gives us we've got a slight complication in the diagram. So I've got dogs, and part of my circle is going to be a solid line, and then part of it is going to be a dotted line. And then I've got that which goes to heaven. Same thing, dogs is my subject, goes to heaven is my predicate. The trick here is that we do not know how much of the subject is encompassed inside the predicate. All we know is that some of the dogs are inside some of that which goes to heaven. We don't know how many. We know it's not the last relationship we looked at. We don't have these two complete circles. Instead, we now have some dogs are in some of what goes to heaven. We know something, but we don't know very much precisely. Everybody with me so far? Okay. But either way, we are talking about all of both of these. And the way this diagram is laid out. So both of these, we'll talk about in just a minute, they're both said to be fully, we're talking about some of each of these. Because when we say some dogs are that which go to heaven, this is the group that we're looking at. And we're looking at some of each category. And again, we don't know how much, which these are both going to be, we're dealing with some of these are both going to be considered to be undistributed. We'll get to in just a moment. All right, our last pattern is similar to an I, but of course, we've got a slight change. Your textbook makes this a little bit different. So here we have an O pattern where some dogs are not that which go to heaven. Now, in one sense, it's very similar to an I pattern where I have and that which go to heaven. Okay. Now, the difference between these two is that, we'll get to more of this in a minute when we talk about distribution, or whether we're talking about all or some, dealing with the comprehension of this. Rhetorically, the focus of this kind of statement is more on what is not happening. So most of my subject is not in the predicate. There's some amount that is, and it's usually going to be a lesser amount than in an I pattern sentence. But, so in representing that, usually this circle comes out with less space is in the overlap than in an I pattern sentence. Because we're focusing here more on this part than on, actually that'd be a better way to represent that. Here we're focusing really on what's not part of the predicate. Some dogs are not that which go to heaven. There might be some here, which is why we can't say that this is an E pattern. But we're going to have some of them or not, and it's really the focus is on what's not in the predicate. So, we have 4 diagrams and 4 different ways of noting this. These are the ways subject and predicates are related. Are there any questions on these diagrams? Okay. With that being said, we're going to move on to topic number 2 today, and we're going to come back to this in a few minutes when we get to kind of the practice side of class in just a few minutes. And with that, let's talk about something called distribution of terms. Now, all of this is the last section of Chapter 5. Chapter 5, Section 7, I believe. So, when we're thinking about the distribution of terms, we need to be familiar with the fact that when we're dealing with a proposition, every term in a proposition, and by that I mean the subject and the predicate, and we take that as a whole. This is part of why I've stressed the brackets as you guys are working on your sentence packets, because we need to think not just of the subject as one word, but as the whole subject. And the brackets help us see that. But the whole subject and the whole predicate is either distributed or undistributed. And here's what I'll put both definitions up. If a term is distributed, what that means is that it is claiming to be universally true of all members of a class. We're talking about all of something if that term is fully distributed. If I was to use the sentence, all cats have fur. Well, in that case, my subject is talking about all the cats. It's distributed. I'm referring to every cat. Okay. Now, a term is undistributed if it is referring to only some members of a class rather than all. Now, the trick with distribution is that the distribution is really set. It's standard based on the format of the sentence. So, I'll show you how this works here in just a moment. So, Dr. Crave gives us these 2 rules, and I'll show you this in the textbook in just a moment. But the subject of an A or an E sentence is always distributed. If I'm talking about all cats have fur, well, my subject is fully distributed. I'm talking about every single cat that exists. If I say no cats have fur, I'm still talking about every single cat that exists. Those are fully distributed subjects. The subject of an I or an O sentence is always undistributed. So here, if I say some cats have fur, as an I pattern sentence, I'm only referring to some cats. I'm not talking about all of them. So my subject is undistributed. Same thing happens if I have an O pattern sentence. Some cats are not that which have fur. Well, my subject is still undistributed. Now, the copula, well, we don't need to worry too much about that rule. But the copula tells us if the predicate is distributed or undistributed. Now, I want to show you a much easier way to do this in just a moment. So, the predicate of an affirmative proposition is always undistributed. So, if I have an A or an I pattern, those are my positive propositions. Those are my affirmative propositions. The predicate is going to be undistributed. If I have a negative proposition, the predicate is always distributed. At this point, everybody grab your textbooks. I want to show you the easier way now that we've talked this through in that format. Okay, turning your textbooks to page 164. Page 164. The rules from this section of this section of the chapter are on the slide. That is the complicated way to do this. There is an easier way, and that's what I'm going to show you, and we'll go from there. On page 164, there are some lovely charts at the bottom of the page. Now, they give you what hopefully is very familiar at this point. All SSP, no SSP, some SSP, some S is not P. What those charts do, though, note that there's some little letters next to them. Where you have next in the Senate, we have all S is P, where S has a D and P has a U next to it. D stands for distributed, U stands for undistributed. In the E pattern sentence, no S is P, where S is distributed and P is distributed. You've got the I pattern, some S is P, where S is undistributed and P is undistributed. You've got the O pattern sentence, where some S is not P, where S is undistributed and P is distributed. This chart is constructed following these rules. So track this with me. Every proposition, that's a declarative sentence, it has to be if it's a proposition, every proposition can be put in one of 4 logical form patterns. Each logical form pattern tells us its distribution. So you can do it the long way by kind of reasoning through these rules, or you can use the chart on page 164. And, there it is. So, let's say I get a random sentence, and I can quickly figure out the distribution. And I'll show you why this matters in just a moment. Dylan, could you give me I need a proposition to work with. Crazy as you want to make it. Doesn't have to be true, real, it just needs to be a declarative sentence.
The flag was waving in the wind.
The flag is waving in the wind? Perfect. Okay. The flag is waving in the wind. Okay. So, first thing I'm going to do if I'm trying to figure out my distribution is I'm going to put this in logical form. Well, here's my subject. Here's my predicate. All right, I have a singular subject, so I'm going to treat that as a universal. So this is going to be an A-pattern sentence. All that which is the flag is that which is waving in the wind. Okay, now, if this is in fact an A-pattern sentence, I could go back here and say, okay, all right, the subject here is distributed by the first rule, and the predicate is undistributed by the second rule. Or I can look at the chart on page 164. Okay, my subject is distributed, and my predicate is undistributed. Done. If I have an O pattern sentence, let's do the same one, but as an O. Some that which is the flag is not that which is waving. Now I can do the same thing. I can go back to the rules and say, okay, the subject of an O sentence is undistributed. The predicate of a negative proposition is distributed. I could do it that way. Or you could go look at the chart on page 164. All right, no pattern goes undistributed, distributed. And done. Either way will get you to the correct answer. Marking distribution is one of the critical pieces of this because it's going to be the rationale for why we can do all the transformations that we're about to start learning. Questions on this? All right. I appreciate y'all's patience. We're going to hit one more thing, and then we're going to shift gears to actually practicing what we've been talking about for the last 20 minutes. Okay. So, the last thing we talk about in kind of a lecture format today is called converting propositions. You've still got your textbooks open. If you turn the page to page 168, you'll see that our next chapter is entitled Changing Propositions. Once we've got a proposition into logical form, it becomes really easy to manipulate it and to change it. We can change it as long as we change it according to certain rules and certain operations that we're going to begin learning today. The first of those operations is called conversion. Now, conversion literally means, I'm going to write this on the whiteboard, because it's written in the book in a couple confusing places. But when we convert a sentence, all we're doing, we are exchanging subject and predicate in a new sentence. We're going to change where subject and predicate are located in the sentence. The subject's going to become the predicate's going to become the subject. Now, when we're doing this conversion operation, we got to follow certain rules, and that's where this whole section is going to come about. So we're talking about the interchanging of the subject and the predicate. So here's the main rule that we've got to follow, and I'm going to show you the trick. I'll show you the complicated way, and then we're going to look at the simple way. There's a very easy way to do this. So hang with me through the complicated one, and we'll get the simple one in just a second. Only terms which have the same property of distribution can be exchanged. Now, if you've still got your books open, you could look back at page 164 on the chart, and you'll notice that in an E-pattern sentence, subject and predicate are both fully distributed. And in an I-pattern sentence, subject and predicate are both completely undistributed. Meaning, I can change those back and forth, and it does not affect the meaning. But in an A-pattern sentence, subject and predicate have different values in terms of distribution. Subject is distributed, predicate's undistributed. In an O pattern sentence, the subject's undistributed, but the predicate is distributed. So I can't just change those two willy-nilly. But if I have a sentence that says, no cat has a tail, that means exactly the same thing if I say no tail is that which a cat has. Identical. If I have a sentence that says some students have hair, that means the same thing as some hair is that which students have. Absolutely identical. And I can do that because they have the same property of distribution. Now, there's one so we'll get very familiar with why this doesn't work. But if you just swap subject and predicate in an A pattern sentence and you just change them just because, well, that is called the fallacy of an illicit conversion of an A proposition. That is possibly the lamest name of a fallacy anyone has invented, but it's very descriptive. If you convert this the wrong way, we mess up the distribution. The reason this is a fallacy is because in an A pattern sentence, in the subject, that's fully distributed, we're talking about all of the subject. And in the predicate, we're only talking about some of the predicate. If we suddenly swap those within an A pattern sentence, then really what we have going on is that's really going to be a problem, because now we're talking about all of what we were previously saying was some. And now we're talking about some of what we were previously saying was all. So we can't do that with an A pattern sentence. Everybody good there? All right, I'm going to do one example of that fallacy on the board. So hopefully that will make sense. Okay. All markers are dry erase. Okay? All right. Subject, predicate. Distributed, undistributed. I'm talking about all the markers, but there might be other things that are dry erase that aren't markers, since this is undistributed. There is more of the there's more going on in dry erase. There could be dry erase. There could be erasers. There might be dry erase whiteboards. So if all of a sudden I just change this and say all that which is dry erase are markers. Well, this is an illicit conversion. This is an illegal move in logic. I can't do this because I went from saying all of this is some of this to all of this is some of this. This may very well be a true statement. This is not. So I can't just swap it because I'd like to just exchange it. Instead, we need to do something a little bit different.
So the S and P have to have the same property of distribution?
Mm-hmm.
Okay, so E.
You can convert an E inside an E. You can convert an I inside an I. And that's where we're going to get to on the next slide. So, E and I propositions both swap internally. No markers are dry erase. No things that are dry erase are markers. Same thing. That's not a problem. So if the distribution is the same, the conversion can just happen inside the same sentence pattern. It saves us a step. So here's the thing. An A proposition changes to an I proposition. What I can do, I can't do what I currently have on the board, where this A becomes this A. I can't do that. But what I could do is correctly, so this is an A. I usually make myself a little note that an A converts to an I. So what I could do is say sum of that which is dry erase are markers. And that's how that works. Now if this one's a true statement, this is also a true statement. The distribution is the same. I just converted it to a form that had the right pattern to fit what I need. Now, the next rule to keep in mind, this is a big one. There are a couple problems will work where you will frustrate yourselves a lot until you remember this rule that if it's an O proposition, this does not work. O propositions simply do not convert. So, let's say you run into one and it says something like some, I don't know. Colin, can you give me a noun?
Dog.
One more time?
Dog.
Some dogs are not three-legged. Okay? You cannot convert this. So on a quiz, test, or practice scenario, the only answer I would be looking for in this one is does not convert. That's it. That's how you just make a note. This one does not work. We can't do this. Dr. Crate gives you a rationale for why that is. And that's in the book if you want to dig through that one. For my purposes, we just need to recognize that this doesn't work. Turn in your books to page 170. Everything I just explained is listed in pages 166 through page 170. There is a box at the top, or there is a chart at the top of page 170. I would highly, 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 highly encourage you to dog-ear page 170 in your textbook. Pages between page 170, page 164, and page 148, we've got 3 really helpful charts. Now, so you will be going back and forth to these throughout the next few weeks. As we work with this, we're going to add some more later on. Next, we might cover it tomorrow, but next Tuesday we'll begin working with the next thing. It's called obversion. But for today, we're just working with conversion. Spencer.
We said 170, 164, and 148.
That is correct. We've got our sentence patterns, our distribution patterns, and our table of valid conversions. Now, the table of valid conversions gives you, and I'll just put it up on the board as well, it gives you these are the ways you convert a sentence. And if you know that conversion means exchanging subject and predicate, then you now know how to use this chart. An E sentence converts to an E. An I sentence converts to an I. An A converts to an I. An E can convert to an O. Class as a group, can an O sentence convert?
No.
No! Excellent. Mr. DeCrisio.
If an E can go to an O, why can't it go back?
It has to do with the distribution pattern of the predicate, and I'm going to try to explain this so that it makes sense. I think I understand Dr. Crave's reasoning. I don't know that I understand it well to be able to clearly explain it, but I'm going to try. So, let's do an example of that type. Okay. So we need an E pattern sentence. No lollipops are sugar-free. Okay, so I've got an E pattern sentence, which means my subject's distributed and my predicate is distributed. So my Euler's circle diagram would look like S and P. Okay, now if I put this, so I convert this into an O pattern sentence, would mean some of that which is sugar-free is lollipops. Okay, so now, make sure I do this right. Undistributed, distributed. The reason this works is that this one is implied by this one. If no lollipops are sugar-free, some of the things that are sugar-free are lollipops. But it's not going to, we can't flip that. If we start with this one, some of that which is sugar-free is lollipops. Because our diagram here is going to look like where we have S and P. Some sugar-free things are lollipops. This one is implied. Right.
It's not, is it?
Did I do this right? No lollipops are sugar-free. So some, oh, haha. That's why. It's not lollipops. There we go, I made it into an I. Okay, so no lollipops are sugar-free. Some of that which are sugar-free are not lollipops. Like this statement is implied in this one, but you can't go backwards because we can't get both of these. This one's now undistributed, so we can't get it to be where it's fully distributed in conversion.
So because some is part of all, but some doesn't necessarily comply all.
Yes, I think
That.
I think we're on the right track there.
Okay.
We are digging into the complicated stuff, and we're building. If you guys were here in 8th grade, you may remember this lovely diagram. I think my arrows are all correct, but we're building to a set of relationships where we can go from one proposition to really everything that it can possibly imply. And we'll get there. We're not there yet. We're still at step 2. We've got to get through a few others before we get there. Okay. All right. With that, you guys have everything that you need to get started on the next piece. So, for the next piece of class, when everybody go to Canvas, you'll see I put 2, I've updated our homepage, updated last night. There are 2 Google Doc worksheets that I want you to make copies of and begin. Start with worksheet 16. It's dealing with Euler circles and distribution. Then go to sentence 17. Now, worksheet 17, and just as fair warning, please don't be thrown by some of the oddities of worksheet 17. When I wrote that last year, students were starting to study Taoism in history. So I decided to have fun and put some Taoist statements in my logic worksheet, and we're gonna change them around. So, with that, we've got the remainder of the bell to work through as many of those as you can. Let me know if you have questions. I am happy to help. Let's get started.